Welcome to another explainer where we take a structured journey into the invisible forces that dictate the prices of literally everything we buy. Have you ever stood in a grocery store or maybe scrolled through an online storefront and wondered why a product costs exactly what it does? It can feel completely arbitrary sometimes, almost like magic. But the reality? Behind every price tag is a beautifully structured system of rules, reactions, and mathematics. So today we're going to demystify those rules together. Here is our agenda for today. 1. The law of supply. 2. Graphing the supply curve. 3. What shifts supply. 4. Elasticity of supply. And 5. Finding market equilibrium. Let's start with Section 1, the law of supply. Before we can even begin to understand the market as a whole, we have to look really closely at how the people making the products actually behave. And to do that, we look at the law of supply. This law states that, ceteris paribus, which is basically a fancy way of saying all else remaining equal, as the price of a product increases, the quantity supplied increases, and vice versa. So there's a direct relationship at play here. Think about it from a seller's perspective. Higher market prices serve as a massive, direct incentive to ramp up production. If people are suddenly willing to pay you way more for your product, you are going to be highly motivated to produce and sell more of it, right? To ground this abstract theory, let's take a seller's supply schedule for butter. This tabular statement shows us exactly what a single producer will do at different price points. And, exactly as the law dictates, as the price drops from 30 birr down to 10 birr, the kilograms of butter supplied by this seller drop right alongside it, falling from 100 all the way down to 60. It's pretty simple. When the financial reward shrinks, so does the effort to supply the market. Moving on to Section 2, graphing the supply curve. Now that we know how a single seller behaves, we can see what happens when we visualize this behavior for everyone in the market together. The supply of a commodity can actually be expressed as a functional relationship, S equals F of P. That just means quantity supplied is a direct function of price. Because of that positive, direct relationship we just established, our supply curve will always slope upward as we move from the left to the right. It visually proves that higher prices invite more goods for sale. But as we know, a market is rarely just one single seller. To figure out the total market supply, we simply aggregate horizontally. By adding up the individual quantities from seller 1, seller 2, and seller 3, at each exact price point, we get the total market supply per week. For instance, at a price of 5, seller 1 provides 11 units, seller 2 provides 15, and seller 3 provides 8. Add all those together, and boom, the market supply is 34. This aggregate number creates the actual supply curve for the entire market. All right, Section 3, what shifts the supply? Up until now, we've heavily relied on that assumption of ceteris paribus, all else being equal. But what happens when we break that rule and things do actually change in the real world? Well, before we get to the answers, I want you to ask yourself a quick question. If the price of butter stays exactly the same, what outside forces could possibly compel a farmer to supply less butter? Think about the everyday, messy realities of running a business. It turns out there are several crucial determinants that can shift our supply curve entirely to the left or to the right. For example, if the cost of your inputs, like labor or raw materials, suddenly goes up, your ability to supply decreases, which shifts the whole curve to the left. On the flip side, what if there's a huge breakthrough in technology? That allows a firm to produce way more efficiently, shifting the supply curve outward to the right. Things like changes in taxes, the number of competitors popping up, and even future price expectations all play massive roles in deciding exactly how much product hits the shelves. A perfect real-world example of this, especially for agriculture, is the weather. A fantastic season of rain pushes the supply curve outward, creating abundance without a single change in price. But a severe drought, that violently pulls the supply curve inward, shrinking availability completely regardless of buyer demand or how much cash people are willing to hand over. Let's dive into Section 4, elasticity of supply. Seeing how all this builds our understanding, we start to realize that supply isn't just some rigid rule. It actually has a bit of a personality in how it reacts. We call this elasticity of supply. It's the degree of responsiveness to a change in price, calculated by taking the percentage change in quantity supplied and dividing it by the percentage change in price. Essentially, it's just a way to measure how incredibly sensitive sellers are to a shift in price. For some goods, a tiny little price jump might cause a massive flood of new supply. For other goods, the price could literally triple, and the supply might barely move the needle at all. This sharp contrast really highlights the extremes of elasticity. A perfectly elastic supply is a completely horizontal line on the graph. It basically means an infinite quantity will be supplied at a certain price, but if the price drops even a fraction of a cent, supply drops to zero. On the totally opposite end, perfectly inelastic supply is a completely vertical line. This means absolutely zero responsiveness. No matter how sky-high the price shoots up, the supplier literally cannot produce one single extra unit. Think of it like the number of seats in a football stadium. You can't just magically spawn more seats just because ticket prices went up. And finally, Section 5, Finding Market Equilibrium. We have officially reached the climax of our story, where supply and demands finally collide. Notice point E here. We have our downward-sloping demand curve and our upward-sloping supply curve directly intersecting. This right here is the market clearing equilibrium. At this exact price level, labeled P, the amount consumers want to buy perfectly, beautifully matches what producers want to sell. There is total harmony in the market. But, as you can probably guess, harmony is fragile. If you look at the upper and lower bounds of a market, you see the pure chaos of imbalance. If the price gets pushed above equilibrium, it creates a market surplus. Consumers are demanding less because it's just too expensive, but suppliers are enthusiastically producing more because the price is high. The result? Goods just sit unsold on shelves gathering dust. On the other hand, any price set below equilibrium creates a frantic market shortage. Buyers want a ton of the cheap product, but suppliers flat out refuse to make it at such a low price. The cool part is, we don't have to just guess where this equilibrium is. We can actually calculate it using a numerical example. Let's say we're given a market demand equation of 100 minus 2p and a market supply equation of 2p minus 20. To find our harmony, we just follow step 1. Set demand equal to supply. So 100 minus 2p equals 2p minus 20. Step 2, we naturally group the variables together, which gives us 4p equals 120. Step 3, simply divide by 4 to solve for our equilibrium price, which tells us p equals 30. And finally, step 4, plug that 30 back into either of the original equations, and we find our clearing quantity is 40. The magic price is 30, and the magic quantity is 40. And this perfectly validates our math while also showing the real-world cost of missing that magic number. Let's say sellers try to guess the price and incorrectly set it artificially low at 25. The math shows demand hits 50, but supply drops to 30. They fall 20 units short, leaving buyers incredibly frustrated. But if they get greedy and jack the price up to 35, demand dries up to 30 while they churn out 50 units. Now they're left with 20 units of totally useless surplus taking up space in their warehouse. Equilibrium isn't just some academic theory. It's the exact target every single successful market has to hit. We've covered a lot of ground today, right? From individual seller schedules all the way to mathematically clearing a market. So, as you step away from this explainer and navigate the real world of fluctuating price tags and empty store shelves, use these building blocks to decode what's actually happening behind the scenes of every transaction. Next time you see a product drastically change in price, I want you to ask yourself a question. Are you witnessing a fundamental shift in supply due to outside forces, or are you just watching a market desperately searching for its equilibrium? Thanks so much for joining me, and keep looking for those hidden structures in the world around you.